Hello. In this fifth video, we'll go over some slightly more advanced aspects of EVPV. So first we'll look at Python scripts to run the model in advanced mode, and then a few scripts also that you can find in the EVPV-Tools repository on GitHub. So we will look at these scripts that are available to pre-process some data or perform additional analysis. So let's start first with the advanced usage mode. So for this, I will reopen the Addis Abeba example first. So let me just quickly go back into that folder. But for this time, I'll open the Python script example file here. Right. So this file here shows how to obtain the same results as with the configuration file, but using Python scripts. Indeed, it's possible, as you see here, to import EVPV as a package and use some different classes within it. And to learn about everything about the classes, again, here you can go on the read the docs documentation in the API section. And so using these classes here, you can achieve the same results as with the configuration file and even more. For example, if I run this script here, so I can just do it here by going back to the folder with the example. Up and run the file that is called Python script example. If I run this, you see that the code is printing out what is going on, and after a few seconds, normally we will have the results of the simulation. Here we are, and if I go to the output folder here, I see that I have a bunch of other output data. So these are basically the same outputs as previously, but we see that, for example, here it's possible to have additional outputs. So for instance here, these are all the destinations, the number of vehicles that go to different destinations, starting from here, the zone here that has no color. Also, additionally, here in this file, it will also show you how to, if you want, apply some smart charging to your vehicle fleet. So you can explore what is happening if you apply smart charging here by uncommenting this line. Note that the only smart charging strategy that is implemented for the moment is peak shaving. And if I rerun the code with that parameter, so here I see that in the info it tries to apply some peak shaving. And if I go to the results, I can, for instance, here open the aggregated demand profile with Excel. And if I plot the load curve for charging at home, I see that I have here a very different profile than previously. We see that it's quite flat here between around 6 p.m. and 9 a.m. in the morning. That is the average arrival times of vehicles at home. Now I also want to show you some of the scripts. To do so, I will just move here my terminal to a folder where I have downloaded all the different scripts. So here I won't go over all of them, just the one that helps you pre-process the data. So first here there is a script called extract points of interest from OSM. So this one uses the USMNX library, which you can install in your environment in order to extract all the different either points of interest or workplaces from OpenStreetMap. So to use that code, so here if you try to run it, it will not work directly. You first need to install USMNX. So this is a very heavy package, so I decided not to include it in the base dependencies of EVPV. So once OSMNX is installed, what you have to do is first adjust the coordinates of the bounding box that will define the region where we are going to extract features from USM. And then you have to specify a list of tags here to get workplaces or points of interest. So here you have some example tags for workplaces, so you can uncomment this, or points of interest that is here set by default. Okay, and then what you have to do is execute the code. And so once the script has been executed, you will end up with a file here called centerpoints.csv that will be in the right format. Now looking here at this file script called merge and crop rasters.py. So this one will help you to merge and crop to a bounding box two different raster files. So this can happen if you have two raster files that are needed to cover your region of interest. So for instance, for Addis Abeba, I have two different rasters so that I can copy and paste here. Actually, to cover the entire zone, I need the two of them. So what I can do is I just here put the name of the files and here the name of the output file, and I just execute the script. So this should be fast, and here as a result I see that I have merged cropped raster that TIFF, which of course is also way smaller than the raw files that I've downloaded from GHS POP. And lastly, I will also want you to show you the extract feature from gadm.py script. And so this one is useful if you download data from GADM, such as data for Ethiopia. And actually, as I said in the previous video, this sometimes comes with the shapes of different features. So that are the different administrative regions of Ethiopia here. And for EVPV, what you want to do is only extract the feature Addis Abeba. So again, you open the file, and here you have to look at find the target name of the region that you want to extract from the GADM shapefile, GeoJSON file, sorry. And again, here you type Python and the name of the script, and here you then have a file called addisabeba.json. And so this one only contains the boundaries of Addis Abeba. Just how to know that here as a target name you have to put Addis Abeba. To find out what you have to put, you just have to open the GIDM file and look at here the feature that has the name Addis Abeba. If you want to extract another region, you can just change the name. Look at the other names that are available. So for instance, there is also Afar and other boundaries that you can extract.